Guys, in this STR8CHEM video, we're going to look at how to write the cell notation for a galvanic cell. So let's have a look at the same galvanic cell system that we have over here. So when you are given a galvanic cell, you should be able to write the half cell reaction equation for the anode and the half cell equation for the cathode. And from there, you should be able to write the overall cell reaction. And from the overall cell reaction, what we can do is we should be able to write the cell notation as well. So to write the cell notation, it's slightly different from what you are going to be writing for the overall cell reaction. So the first thing you need to do is you need to write these boundaries. So you're going to have 2 lines in the middle like this. Okay. And that will be your, this one will be representing the salt bridge. Okay. And then you're going to have one phase boundary right over here and another phase boundary right over there. Okay, now you have phase boundary number 1, the salt bridge, and phase boundary number 2. On your left hand side, typically what we're going to write on here is going to be the anode. And on the right hand side, okay, on the right hand side, this one will be representing the cathode reaction. So when you look at the overall equation on top, you have zinc going to be converted into zinc 2+, so that is going to be the losing of electrons. Okay, when you look at your zinc, it is obvious that the zinc process over here, from there to here, that is the oxidation, because you are losing electrons. And for copper, what happened there, that is the reduction process, because you are gaining electron. Okay, and then when you have reduction, remember the mnemonic rad cats. If you still remember mnemonic rad cats, reduction adds cathode. So copper 2+ to be reduced into copper solid. So you're going to write this down here. Okay, so that is the one that you're going to write here. So what you're going to have there is going to be the aqueous. Okay, so you're going to have the aqueous and the solids right there. Okay, so when you write the Cu2+, don't forget the phase, and for cell notation, you have to write along the concentration of it. So Cu2+, the concentration is 1.0 molar. Okay, so you're going to write 1.0 molar in brackets, just like that. And over this side, you have copper solid. Okay, so the process now is from here to there, it's gaining electrons. Reduction happens at cathodes. So for the zinc solid to be oxidized, becoming zinc 2+ aqueous, so we're going to do similar things. So zinc will be on this end, zinc solid, and the zinc 2+ will have the aqueous phase, comma, and Make sure you're going to write the concentration of zinc 2 plus aqueous, which is 1.0 molar. So you're going to write 1.0 molar. You're going to close that brackets. So this is how you're going to write the cell notation. Okay, don't forget to label your anode. So that is going to be the anodes. Label your salt bridge. Okay, and then you have to label your cathode right over here. So it's still going to be in the A, B, C arrangement. Okay, from left to right, you're going to have the anodes, salt bridge, cathodes. So the electrons will be flowing from your anodes to cathodes. Let's have a look at another example. So let's say we have this example over here. This time when you look at the overall cell reaction, you have 1 mole of iron solid to be reacting with 2 mole of Ag plus aqueous. You have 1 mole of Fe2 plus aqueous on the product side, and you have 2 mole of silver solid. Okay, so this is the overall cell reaction. So how are we going to write the cell notation? So this time it's going to be there's a thing that I need to emphasize over here, and it's good for you to know. Okay, so let's say the concentration of the electrolytes is at 0.5 molar, and you have the overall cell reaction above. So what you're going to do is still, first you're going to do the boundary. So we're going to do the salt bridge first. So that is the salt bridge. Okay, don't forget to label your salt bridge. I'm going to put it there, arrow, and that is the salt bridge. And then we're going to put another phase boundary right there, and another one right here. Okay, and as usual, this part will be your anode, and this part over here will be your cathode. And when you look at the process, what's going on here, the iron will be undergoing oxidation process because it will be losing electrons. Remember, oil rig, O, oxidation, I is, and L is losing. So it's oxidation is losing of electrons. So oxidation will happen at the anodes because, remember, red cats. So when you have reduction over here, okay, reduction, red cat, reduction will happen at the cathode. Okay, so we're going to do for the anode first. That's okay. Not a problem at all. So you're going to write the iron solid with the iron 2 plus aqueous, and the concentration is 0.5 molar. Okay, and you're going to write the Ag plus aqueous. So for the cell notation, you don't have to include the stoichiometric coefficient over here. If you look there, you have 2 Ag plus, but you don't have to include that in here. You're just going to be writing that as Ag plus brackets aqueous, comma 0.5 molar, and then you're going to put close to that brackets. You have 2 Ag solids over there. You don't have to write the stoichiometric coefficient in here. You don't have to write it. You're just going to write silver solid. So when you have this written down, all complete, you will be able to get 1 mark. Same goes to what you have over here. You will be given 1 mark for your cell notation. What about reactions involving gases? For this one, the cell notation will look quite exotic because you're going to have more than 2 phase boundaries, because right now you're going to be involving platinum in your cell notation, because platinum will be the medium for the reaction to happen between the gas and the electrolytes. So what do I mean over here? Let's say we have the overall cell reaction. We have nickel solid plus Cl2 gas, and you have nickel 2 plus aqueous plus 2Cl minus aqueous. So when you look there, you have gas, okay? This one is slightly different from what we have done. Usually you're going to have aqueous over here, aqueous over there, and you're going to have solid to be formed there. But even though this one looks slightly different from what we have done previously, the concept is still going to be the same. So before we're going to go through the concepts, look at the phase boundary. We have 1, 2, and 3. Why do we have one additional phase boundary over here? Because at the cathode, the gas will be undergoing the process of reduction by gaining electron. And since at the cathode, you're going to be involving the gas, you need to have a platinum rise over here. Okay, so we're going to do that afterwards. And let's say you have the concentration of the Ni2 plus aqueous 0.02 molar and the concentration of Cl minus 0.1 molar, and the pressure, okay, the partial pressure for the chlorine gas is given as 1.0 atmospheric pressure. To write the cell notation for this, we're going to start with identifying who will be reduced, who will be oxidized. We're going to apply the same type of technique. So anodes will be the one oxidized. So oxidation is losing of electrons. So the one that will be losing electron between nickel solids and chlorine gas over here is nickel, obviously, because on the product sides, the nickel solids will be converted into Ni2 plus aqueous. So this is the oxidation process. From nickel solids to nickel 2 plus aqueous, that is oxidation. Okay, so that is oxidation process. This is oxidation process, okay? And when you look at here, chlorine to 2Cl minus, the chlorine gas will be receiving electrons and it will be converted into 2Cl minus. So that is the reduction. So chlorine gas will be undergoing a reduction process, which will be happening at the cathode, and the nickel over here will be undergoing the process of converted into Ni2 plus aqueous oxidation process that will happen at the anode. Let's write for the anode first. So we have nickel solids to be converted into Ni2 plus aqueous through oxidation process. So here you have nickel solid and will be oxidized into nickel 2 plus aqueous, and the concentration is 0.02 molar. Okay, and for the next one over here, you're going to write the aqueous first over that side. So you have Cl minus aqueous, and the concentration is 0.1 molar, followed by the gas. So you have Cl2 gas 1 point, write it Cl2 gas, and the pressure, don't forget. And then at the end over here, since this is concerning about gas, so whenever you have gas, you have to include the platinum solid. So that platinum should be together in the cathode. Okay, so this is how you're going to write the cell notation if you are involving gaseous species in your galvanic cell process. So by having all of this written down correctly and labeled completely, you will be given 1 mark. Now we have something slightly different. So instead of writing the cell notation from a given overall cell reaction, you are instructed to write down the half cell reactions and the overall reaction for the given cell notation over here. Both of them are in the phases of gas. You have the anodes in gas and the cathodes in gas as well. Okay, do you remember this part over here representing the anode, salt bridge, cathode? So that's how you're going to read the cell notation. So at the anode, okay, do you remember anode is losing of electrons? So you're going to have H2 gas right here, and it will be losing electrons, H plus aqueous plus electron, and you want to balance that out. You have 2 mole of H over here, so you're going to put 2 there, therefore you're going to have 2 here as well. So for the anode, that one is okay because you are losing electron. You need to remember H2 gas loses the electrons and converts it or oxidizes into H plus aqueous right there. What about the cathode? Cathode is the gaining of electrons. So you're going to have the Br2 gas gaining electrons, and you'll get Br minus aqueous. And to balance this, you have 2 Br over there. You're going to put 2 here and 2 there. So the overall cell reaction, you will have to cancel that. You have 2 moles of electrons on the opposite side, so you can cancel that out. And when you combine, you'll get H2 gas plus Br2 gas and you'll get 2H plus aqueous plus 2 Br minus aqueous. Okay, so you'll get 1 mark for this, 1 mark for the cathode half cell, and another 1 mark for the overall cell reaction. Do remember to write down all the phases correctly. Okay, if you forget to write the phases, you won't be able to get your mark. If you want to draw this diagram, it's going to be slightly different from what you have drawn before. So if you want to draw the diagram for the galvanic cell involving gaseous species, you're going to draw it in this form. Okay, so you have this glass vessel over here, and you're going to start pumping the gas inside. So the gas will travel down the glass, and the reaction will start to happen on the platinum. So the platinum is just an inert catalyst. Okay, so it's just going to be preparing the medium for the electrolytes, for the H plus aqueous to be able to be reacting in there. Okay, so this is how you're going to draw the galvanic cell for gaseous species. Okay, so if you have gas, you need to draw the glass vessel over here, the tube, and the platinum with the wire connected to the platinum, and you're gonna have the gas to come in from that side. Since this side is also in gaseous form, you also need to draw it in a form like this. So do remember, this format of drawing is only applicable for gaseous species. So if you have solid electrode, you can draw like what we have drawn in the previous video.